this evening here where I am. Welcome. For today's lesson, I don't know what we're teaching yet because I have not received any information on the topic. But doesn't matter. We will wing it as usual for these certain cases. All right. So our student today is Ariana again. Um, we will be starting in a few seconds, and I'm gonna welcome her in the stream now if she's there. Hi, Ariana.
Hello,
How are you today?
I'm good. How are you?
Doing good, thanks for asking. Okay, hold on, let me change my volume settings. I cannot hear myself.
Okay.
All right, there. All right, that works. Okay, so what are we doing today?
Okay. Hold on. Uh, like, the inverse of functions and wait, no, not that. The square root, square root functions.
Square root functions. Okay.
Where it's like halfway, and I'm just like, oh.
Okay, is there anything else?
Um, we also learn about inverse functions
Inverse
and
functions.
mhm.
Okay. And what else?
And I think that's about it. Besides operation of functions, but I think I got that part down.
All right, the operations. They're actually rather easy, so we're good with that.
Yeah. So I
Uh,
think I got that one down, but I think the other two are what I'm working on.
okay, sure. All right. Um, okay, let me just get ready real quick here. Okay. Okay. What I'll do here is I'll just take a quick look at what exactly you should be learning here. So,
Okay.
just give me a few moments and then we can start there. Okay.
hmm Also, by the way,
Mm-hmm.
we recently took the quiz to see what math we will be placed next year.
Mm-hmm.
So I might get a result soon. So then, yeah,
Okay then. Well, are you like looking forward to getting to the more advanced classes?
I'm hoping.
Mm-hmm. All right. Uh, all right then. So let's see where we go from here. Hopefully, that's get good news by the end of the week. Yeah.
Yeah.
Okay. All right. Okay. Give me one more moment here.
hmm
Huh? And for inverse functions, that's pretty easy actually. I want to make sure that I understand that I'm teaching the correct one here for square root of functions. Okay.
Okay.
Okay. Okay. I think I got it. All right. So let's start. Okay.
Okay.
Uh, let's just. I think I'm gonna start with inverse functions. Okay, because once
All
we
right.
understand that, then we will understand what the square root of a square root function is. Okay, so
Okay.
um, so if oops, let me change my pen to something thicker.
hmm
Okay, can you see that better?
Yeah.
Okay.
Do I need it?
Oh yeah, speaking of, hold on, let me share the Jamboard link with you before we do anything else. Hmm,
hmm
where's the Jamboard? Here we go. All right. You can see my board though, right? on the screen?
I can see it.
All right, great. All right, so there's the board link, and let's start. So when we see inverse functions, it's gonna be easier to think of inverse functions because normally when we say function, we have some sort of f of x equals something. That's the function, right?
Hmm.
Okay. Now, technically speaking, this is always how you should think about it, but I like to think that this is a where we can start better. So y is equal to some function of x and equal to something. So this particular thing is important. Okay.
Hmm.
Um, if this is the function, then the inverse, the f inverse of x, is basically saying you get your y equal to some other function as well, or some other thing as well. Okay.
All
Now,
right.
um, I forgot personally, I forgot what that definition of the inverse of a function is. However, it's
Oh.
much easier to see what it actually says. Okay, so I'll give you an example
Hmm.
first. Let's do f of x. Let's keep it simple, equal to 3x. Okay,
Mm.
so again, we want to think of this as being equal to y, right?
Okay.
Now, the inverse function, f inverse of x, will be equal. You will do it like this. You will start by taking this, and in the process, you switch the positions of x and y. Switch
Hmm.
the positions of x and y. In other words, any x you see there, you're going to change to a y, and any y you see there, you're going to change to an x. So in this case, I'm going to write it as 3y first, 3x first, equals y, and then I'm going to swap this with y, and I'm going to swap this with x. That's the inverse of the function. Easy
Mm.
enough, okay? And then,
Okay.
um, all right, and then you're gonna rewrite, and the next step here is to rewrite this so that y is the subject.
Mm.
Write this so that y is the subject. Okay.
Hmm.
So how will I rewrite this so that y is the subject? This is now going to become y. Oops, y is equal to x over 3. And this is the inverse function of x.
Ooh.
Okay. Now, in this example, it's pretty easy to see how to do it, right? Okay. So I want you to try this first with an easier example. I'm gonna write an f of x here is equal to 5x plus 1.
Hmm.
Okay. So you wanna go give this a try, find the inverse function.
So you replace x with y and y with x, yeah?
Mm-hmm. So yeah, but remember you have to write the equals y here.
Oh yeah.
All right, that's correct so far.
But
Then you
that's
should.
supposed to be x, right?
Mm-hmm. And then make the subject y.
Hmm.
All right,
You like
after this,
divide
I'll give you
both.
another one.
Okay. And then you minus one and bring it to the other side, I think.
Mm-hmm. Okay, almost right.
Hmm?
Almost right. Because remember, you have to move the negative this one to the other side first. You have to subtract one first, right?
Oh yeah.
So
E.
this means your denominator should be all over x minus 1, not just over x.
Oh.
Okay. So again, so again, I'll just redo that real quick. So again, this should be correct so far. 5y plus 1 equals x. Then minus 1 first, right? So we're left with 5y equals x minus 1. And finally, divide both sides by 5.
Oh.
We get y equals x minus 1 all over 5. And that's your, again,
Oh.
f inverse of x. Okay? Alright, let's
Mhm.
do another one. I'll give you another one here. Let's say f of x is equal to 2x plus 2. So again, don't forget to
Okay.
write the equals y first.
Mhm. Equals y.
Mm-hmm.
2y plus 2
Mm-hmm.
equals x
Correct.
minus the 2 first.
Mm-hmm.
And you also divide it by like x minus 2. Then divide it by 2.
Mm-hmm. Correct. And correct.
Would these two cancel out?
Not, they would, but I wouldn't do that anymore.
Mm.
Okay. Mm-hmm. Great. So, and don't forget at this point to write equals f inverse of x.
Oh, yeah.
Okay. All right. Now, the
Mhm.
thing you were saying, can you cancel the 2? You could, but you could only do that if you separated x over 2 minus 2 over 2.
Mhm.
So once you do this, once you separate the numerator into its parts, then you can cancel that. That becomes 1. But this still remains x minus 2. Like that.
Okay.
Okay. All right. So I think that's pretty straightforward. Now let's go to the square root function.
Mhm.
Okay. Okay. Now the square root function is just the inverse of the quadratic function.
Mm.
Now, why do we say that? Because we know if we just deal with numbers, if we have a square number, for example, 4, we take the square root of that, that becomes 2. This is the same as saying um, 2 squared equals 4, right?
Mhm.
Okay. Um, okay. Another way of doing this is if you have negative square root of 4, that's going to be equal to 2. It's the same as saying um, negative 2 squared equals 4, right?
Mhm.
So that's what we do with numbers. So if you have a quadratic formula, or rather a quadratic equation, what did I say quadration here? I just smashed them together. Okay. Oh, by the way, before we continue, since I'm thinking about it, on the stream, right? What I normally do with the stream now is I take shorts.
Yeah.
I make shorts out of the stream.
Ooh.
So usually the shorts are like one video, one serious video, one example of how to do whatever we're doing, and then one kind of find the mistake. This will be the find the mistake part.
Quadration.
Quadration equation. Okay. All right. All right. So anyway, this is the whole idea. Now, if we take a look at this, let's give a quadratic equation. So let's say that f of x is equal
Mhm.
to uh let's keep it simple first. 4x squared, right?
Mhm.
Okay. So what's the inverse function of this?
Uh. So then do the y thing, right?
Right, exactly.
Would we divide it
Mm-hmm.
by 4 first? Yeah.
Yes. Mm-hmm. You can do that. That's one way to approach this. Okay, so far correct. Hmm. Okay, great.
Yeah, I think.
Okay, we can still further simplify this, but again, let's just do this quickly. So this part's correct.
Hmm.
You switched over the y's and the x, right? And then
Yep.
you divide by 4 here, correct? And then you took the square root for the whole thing, correct? And then the
Uh
square
huh.
root is
Yeah.
for the whole thing, yeah? So let me do that
Yes.
brief correction there so it's easier to see.
Okay.
Okay, but I think that's what you meant anyway. It's for the whole thing, right?
Yeah.
Okay.
Yeah.
What you can do here is because 4 is also a square, you can kind of bring that out. So you can write this as y equals square root of x over square root of
And half.
4, and you can take the square root of 4 as 2, right?
And then
Yeah.
just keep x as squared
Mm-hmm.
or square rooted.
Yep.
Okay.
All right. That's basically it. So this
Mm.
is already a square root function.
Ooh. And the negative.
Okay.
I.
And you notice we don't have a negative there somewhere.
Mhm.
Okay, that is
Oh
by
yeah.
the okay. That's by design simply because of the fact, excuse me, that if you put a negative number in if you put a negative number here, you won't have an answer in the real numbers, right?
Yeah, that would be imaginary, right?
Correct. Correct. Okay. Uh, okay. Now we could do this with more complicated examples, but I think we will suffice at least for this point to stay within the x squared bits. Okay.
Mhm.
Uh,
We haven't done anything with imaginary for this yet, so.
mm-hmm. All right. Let me just check something else just to be sure. All right.
Well,
So,
graphing.
all right. So anyway, let's go back to this. What's your function of x? If your function of x is equal to the square root of something, right?
Oh.
Okay. You can actually add some other numbers here. So we'll just call this number a plus a here, and then plus b on the outside. This
Uh huh.
qualifies as part of being um, quadratic, not quadratic. This qualifies as being a square root function. Okay,
Ooh.
this is the general form.
Mhm.
Okay, now the one more property. Let's discuss the properties first. Okay, so first of all, what's a domain of f of x?
Um. Is would it be the a like
Okay,
greater than or equal to
exactly. That thing inside the square root should be bigger than what number?
whatever a is?
Okay, so should be greater than or equal to. We can so x can be a, right?
Yeah.
Can it be less than a? Actually, let's not put it as
Yes.
a. Let's put it as minus because I think that's gonna make it easier to see. So can x be bigger than a? Yes, right?
Yes.
But can x be less than a?
Yes.
No. At least for real
Oh.
numbers. Okay, let's only
Okay.
assume real numbers.
Okay.
In real numbers. Okay, so
Okay. So
what do we get?
yes. I know.
So this should be greater than or equal to 0, right?
Mhm.
Okay, how about the range?
Oh wait. I think I
Okay,
got domain and range mixed up.
okay. Let's kind of go back here. You got them mixed up. What
Yeah.
do you mean by that?
I think I just forgot. Sometimes I think domain is the width and then x and then no domain as y or x and then range as y or x.
Mm-hmm. Actually, yes, a lot of people get confused by this. So we're clear,
Mhm.
yeah, domain should be the x, okay, and range
Mhm.
would be y or f
Yeah.
of x, right?
Yeah. Yeah. Yeah.
Okay, there. So what's the range of f of
Mhm.
x in real numbers again?
Um, greater than or equal to b
Correct. So
or
f of x
yeah.
should be greater than or equal to b because of the fact that this
Mhm.
can only be 0 minimum, right?
Yeah.
Okay. So, all right. What other properties do I need to discuss briefly here? Um, okay, I think we'll keep it there, and then we'll go to the last one. Now, if we go
Mhm.
only to the very plain square root of x, okay, okay, so let's discuss these following. In fact, I am not gonna write this. It's gonna be faster if I just copy and paste this from the source. Uh, just copy this, and I'll tell you what my source is.
Mhm.
All right. So these are the properties of f of x equals square root of x.
Mm.
Okay. So as it says here, the domain is from 0 to positive infinity or greater than 0, inclusive, right? Range is the same,
Mhm.
positive infinity, 0 to positive infinity. It has no relative maxima, but has a minimum of 0, 0. In other words, there is no um, maximum possible value, right?
Ooh.
Okay.
Okay.
Um, okay, a square root function has no asymptotes. That's another property there. It's also always increasing, and it has a critical point, no inflection points. Have you learned critical points yet?
Critical? I don't think so. No.
Okay, so I guess for now we will skip this particular property for you. Okay.
Okay.
All right. I'm just gonna discuss this briefly. The critical point is a sort of this is the point where the slope changes from either positive to negative or negative to positive. Okay.
Mhm.
I'll just put this here. The point where a function, okay, I'm gonna put that in the word that this for now because you haven't learned this yet. But basically, if it's like if you're like if you're like taking the slope of the function at a particular point, um, where it changes from plus to minus or minus to plus. Okay,
Mhm.
so this again, it will become more clear um, when I show it on the graph. Okay, so
Mhm.
usually for the square root of a graph, and this is where we'll end with the lesson, not the lesson, but the lecture
Mhm.
part. Okay, then
Mhm.
we'll do some exercises. Now, excuse me.
Yay.
All right, so this is the graph of what f of x looks like. F of x equals square root of x, something like this, right?
Kind of like half a function.
Mm-hmm. Now, if you kind of extend this by getting the negative square root of x on this side, you'll get something like this.
Ooh.
Negative square root of x like that. You get something like this, right? Now you will see here that this
Mhm.
kind of looks like a line, and the line has a positive slope, right?
Mhm.
So is this region, and so does this region. All of these have positive slopes, right?
Mhm.
But here, okay, wait, hold on. It doesn't look like that. I will redo this bit. But my
Okay.
my point still stands that it should look like this. Zero,
More
zero,
curved.
1, -1, 2, -4 should be, yeah, it's something like that. It was like that earlier. So it's
Mm.
still gonna follow the same general curve, but it's like reflected, right?
Mhm.
So here it's also kind of positive, but here at 0, there is, it kind of turns, right?
Mhm.
Okay, at 0. So the behavior generally changes because if you think about this, if this were really continuous, it's gonna go like this, but it doesn't. It turns.
Mm.
All right, so that is a critical point if it turns like that. So I guess it's better to say this here, the point where a function turns. Okay.
Mm.
There's a more there's a better definition later on, but for now, we'll just say it like this. Okay.
Mm-hmm.
All right. Okay. So, all right. So with that in mind, let's look at some exercises here, and basically say um. All right. I think there's one more thing. Okay. So I wanted to try to graph this particular function. Okay. It's gonna be
Mm.
difficult here on the Jamboard. So if you'd like to use like uh a graphic calculator, or you if you'd like to use Desmos here, you can go ahead do so. Just get the
I will
graph of
try
this
my
thing.
best.
Yeah. Okay. I'm gonna try giving you a grid. Hold on. I'm gonna set the
Okay.
background to a grid. There we go.
Ooh. Oh, you can do that?
Yeah, you could do this in Jamboard. I haven't used
Oh, I
it in
didn't
a
know. Why
while.
are they removing this?
Oh, you don't know how to do it. Okay, let me show you how to do it in
Oh,
case.
oh no, why are they removing?
Yeah, I know. It's really nice. This is a really nice feature, isn't it?
Mm-hmm.
Hold on. Let me change the settings here so you can see this first. Let's remove that. Okay. You can see the whole board for now, right?
Yeah.
Okay. Um all right. Where did my Jamboard actually go? Here. Okay. So for you to do that, here, click on set background. And there are your
Ooh.
choices. You can even customize a background.
Mm.
I'd do this. So the grid you're looking at is this.
Ooh, okay.
Okay. All right. Let me put that back up.
Just like
Anyway, for those on the stream who's gonna watch the stream later on, I'm sorry I cannot give you the full link for privacy reasons. You could have partially seen the link, but you don't have the full link. Sorry.
I'm just gonna label these.
All right, go ahead.
Is like the thing like with the -2 be like, wait, why did I write it? Um, be like kind of like the thing where it's like inverse, like kind of like the what's it called
Mm-hmm.
again?
The
So
inverse of
with
the
the if it has negative, it would mean positive, like that
yeah,
type of thing.
yeah.
Okay. So this is x. This one, yeah.
Mm-hmm.
And this is y. So 1, 2, 1, 2. Yeah. Wait, is it the same for the last one or no?
It should be
Is it
the
or is it
same.
downwards?
It should be the same. The shape should always be like that if this were positive. Oops. Let me don't do that. Okay. So
So
if
would
this were
this be
positive,
going with
this, go ahead. Sorry.
would the 3 be going
Okay.
positive or negative?
The three would make it go. Well, think about this. Think about it this way. If you don't know, always imagine that this whole thing is zero.
Mhm.
So if this were zero, without the three, it would be here, right?
Mhm.
But with this plus three, what happens to it? It moves up. All right.
Okay.
So
Mhm.
here, whenever you're adding something here, you're shifting it up.
Okay.
Okay.
So then there would be
So let's put
2,
that
3,
here. Uh, shift.
and then that or something.
Yep. Looks like
Hmm.
that looks correct. Okay. hmm
Hmm.
Yeah. All right. Good. All right. So that's how the graph looks like in this case because we're not really expecting you to. calculate everything, this should be accurate enough, right?
Yeah.
Okay. Now, the next thing is we're gonna keep that same function. Okay.
Mm-hmm.
Um, okay. Now I'm gonna ask you now to find the domain. Find the domain, the range. What else can we find? And the horizontal and vertical shifts.
Mm-hmm. The domain is gonna write D for that.
Mm-hmm.
Um, should be X. Yeah, X is greater than or equal to 2.
Mm-hmm.
And range should be Y is greater than or equal to 3.
Mm-hmm.
Um, can I help with the shifts?
Okay. All right. So again, um, okay, the shift, the vertical shift we already know, right? How do you do
Mm-hmm.
vertical shift? Always assume that this is 0 and
Mm-hmm.
compare that to without the plus 3 to with the plus 3. It goes up, right?
So shift 3 up.
Yep. Shifts 3 units up.
Oh, V equals 3 units.
Okay. How about the horizontal shift? This is a bit, it's not really that tricky, honestly. Now,
Hmm. I think I was just confused on what it meant. I was just like, huh?
mhm. Now again, let's think about it this way. When to find the horizontal shift, you're gonna look inside the square root, right? So compare that
Mm-hmm.
if this was only x. So that's always the key idea. Compare to square root of x, right?
Mm-hmm.
And then for the vertical shift, vertical shift, compare to um, y equals um, whatever when x equals 0, okay,
Mm-hmm.
to y equals 0. That's it.
Mm.
Or better yet, compare y when x equals 0 to y when x equals, well, x minus 2 in this case equals 0.
Mm-hmm.
Okay,
Kind of looks like an equal.
all right. So this is the idea. This is all correct now. Okay,
Mm-hmm. Okay.
right, great. So let's make it harder.
Oh.
We're not done yet. We're not. That's still like intermediate. Okay, all right. So the last form here is this f of x is equal to, I'm going to write now letters like this, a times x, uh, sorry, not x first, let's put a b times x minus h, okay,
Mm-hmm.
plus k, okay. Now again, I know you've learned this before, so let's just take a look at the actual ideas on why those things are like that, okay. What is this k again?
Okay.
This k is the
That's
translation, right? K is
Y.
vertical translation. In other words, it moves up and down, right?
Mm-hmm.
Okay. And then what is h? H is the
Uh, the X. One of the X. The
Something related to
horizontal.
the x, right? Okay.
Mm-hmm.
Um, if I'm not mistaken, I'm gonna double check this real quick, okay? But if I'm not mistaken, this is the horizontal translation.
Mm-hmm.
I'm gonna check this real quick, yeah,
Mm-hmm.
before we continue.
Okay.
Okay, give me like a few seconds. Let me see if this is correct. Yep. Right. H is the horizontal translation, definitely. Okay. Now, what do A and B do? A and B will stretch out your graphs somehow.
Mm-hmm.
Okay. Uh, okay, let me just double check. Yep. Mhm. All right, so that's correct. So the A and B, so A and B stretch out the graphs. Okay, or the graph. Now, what does B do? It stretches A stretches it vertically.
Mm.
Okay, then B will stretch it out horizontally.
Mm-hmm.
Okay, let's take a look at okay, so let's take a look at the real quick example. I want you to compare. So I'm gonna check the background again. Compare f of x equals square root of x squared versus g of x equals, let's do the whole thing, okay? So that's gonna be
Mm-hmm.
2 square root of um, 2 times x minus 1 plus 3.
Mm-hmm.
Okay, so I'll set up the graph for you here to make it a bit easier. Okay, there we go. So this is x, this is f of x. Let's make it every two squares is 1 unit. Okay,
Mm-hmm.
and so on and so on. Okay, you wanna go try graphing this, and then let's compare how it looks like. Okay.
Mm-hmm.
Um. Okay, I think we need to compare f of x, and g of x here, right?
Mm-hmm.
Okay, I'll move this later, but what do we want to compare? We're gonna start with 0, 1, 2, 3, and 4. Okay, so if we start with this, I guess the f of x is pretty easy to find. What's it's gonna be 0, it's gonna be 1, 4, 9, and 16, right? How about g of
Mm-hmm.
x? What's that gonna be equal to? So let's put the values in. X minus 1 at
X
0,
minus 1. Mm-hmm.
negative 1, right? So
Mm-hmm.
negative 1 times 2, negative 2. No real roots, so we'll just keep it blank, right?
Mm-hmm.
Okay, g of x, what's that gonna be? X minus 1 is 0 times square root of 2. Times 2 is 0 still. Square root of 0 is 0. Times 2 is 0 plus 3, this is gonna be 3.
Mm-hmm.
Okay, similarly, 4 minus 1 is 3 times 2. 3 times 2 is 6. So 6 is not really an easy number to get a square root of, so that's gonna be left with 2 root 3 plus 3, right?
Mm.
So if we
Mm-hmm.
put that in the calculator real quick, that's gonna be square root of 3 times 2, sorry, square root of 6 times 2 plus 3. That's gonna be 7.8.90, 7.90. And then the last one, 4 minus 1 is 3. 4 minus 1. Oh, hold on. Did I do that right? 3 minus 1 is 2 times 2 should be 4. Oh, okay. I did this wrong. This is a 7 point. Ah, no, that's still wrong. I'm gonna redo.
Oh.
Hold on. I think this is wrong. So 3 minus 1 is 2 times 2 is 4. Square root of 4 is 2 times 2 is 4 again. This is 7.
Oh.
Right. So this is 7. And this is the one that's uh, we'll redo 2. So 2 minus 1
Okay.
is 1. 2 minus 1 is 1. Times 2 is root
Mm-hmm.
2. So root 2 times 2 plus 3. So that should be it. 2 square root of 2 plus 3, which is approximately, okay, let's do
5.
this one. 2, take the square root, times 2 plus 3 is 5.83.
Mm.
Okay, and finally, let's do the last one. 4 minus 1.
Mm-hmm.
So let's do that on the calculator. 4
3.
minus 1. 4 minus
3.
1 is 3 times 2, 6. Take the
6.
square root, then multiply by 2, then plus 3. Okay. I'm just gonna give the approximate answer. This is the 7.90. Okay.
Mm-hmm.
All right. So how will this graph look like now? I guess we can graph only to 3 to make it fit.
Oh. So we like both of them, right?
Mm-hmm. So let's kind of color code this. Let's use green for f of x, and then let's use red for g of x.
Okay. So f of x, would it be like, or like here maybe?
Mm-hmm.
Oh.
Okay. That's first.
1.
Mm-hmm.
Should I make the dots first maybe? I don't
Yes,
know.
make the dots first.
Okay.
2, then 4. 2, 4.
Um 2, and then up here, right?
Mm-hmm.
3.
And 9.
Okay, we're not going to 16.
Yeah, we're not going to 16. I don't think it's gonna fit, right?
Uh no.
Something like that. Okay.
Beautiful line.
Okay. Something like that. Okay, good. The next one.
There's nothing for 0 here. And then so 1 goes
Uh-huh.
to
Hold on.
starts at 3.
I think I made a mistake again. I am so that's not 2, that's squaring them. That's not gonna be the graph, right? It's gonna be square root of 2. This is
Oh no.
1.44. This is approximately 1.4.
Oh no.
Right, okay, my mistake there. That's the square root of 3 is 1.73.
Okay.
And this is gonna be 2. Oh, that's gonna make a whole lot more sense.
Ooh. So wait,
All right.
1 goes to. Should I regraph? I'll regraph F later.
Okay, sure.
I'm gonna do G now.
Okay, I'll redo
F
the
lost its chance.
yeah, I'll redo green. You do
Okay,
you do the red
I'll
one.
do G. This then 2 is 5.8, so that would be close to 6. Right there. And then goes to 7.
Or something like that, right?
790. Almost touching, but not there.
Okay.
And it starts right there. Right.
Mm-hmm.
Yeah.
Something like that, right? So you see what happened?
Yes.
You see what happened here?
Hmm?
We're graphing the same. Okay, how about this? We don't extend it all the way. Let's just extend it
Hmm.
to where 4 is, right? 4,
Hmm.
2. So I'm gonna erase this bit, and then for you, you're gonna erase 7 point. Okay, there. So what? Okay. So the plus 3, this plus 3 here made it go up, right? Oops.
Hmm.
Okay. So h equals plus 3 shifted 3 units up, right?
Hmm.
Okay. Now, how about the a? How about the k equals 1?
K equal 1.
What did it make? What did it do? It shifted 1 unit, right?
Yeah.
So shifted 1 unit to the right, right?
Hmm.
Okay. What did b? This is b, right? What did
Hmm.
b do?
Oh, let
Equals
me let me look.
2. Okay. Remember, b affects the x part, right?
Yeah.
Mm-hmm.
So
Okay. So,
uh, kind of we could like fraction or something.
all right. Why are you making a frog over there?
I
Okay.
don't know.
All right. No worries. No worries. Because here's the thing. The b, let's kind of extend this to 5 so we can actually see what's happening. But we're not going to do the 5 here. Okay.
Okay.
All right. We're just going to do here for 5. What's that going to be for 5? So let's put that in the calculator again. So
Hmm.
5 minus
So
1,
5,
4 minus 2.
4 times 2 is
Sorry,
8.
not minus 2, times 2. So that's going to be 8. Then we take the square root times 2, then plus 3, right?
Hmm.
So that's 8.66. So if we
Hmm.
graph that for red, I'll just do that for now. Okay, so for 5, 8.66 should be somewhere here. So it curves more like that, all right? And again, we're going to end it
Yeah.
right there.
Hmm.
Okay, basically that 2, okay, the A and the B, they really shift the thing. It's kind of difficult to do this if you have both an A and a B. It's actually a lot
Hmm.
easier if you just have an A.
If you only have one of them.
Yeah, if you only have the A usually. Okay.
Okay.
However, let's
Hmm.
just see what happens.
Also,
What is? I'm just curious here. I'm gonna calculate what is the square root of 2 times 2. Okay, 2.82. That's approximately 3 times as much, right?
ah. Uh-huh.
Uh-huh. Now let's take a look at what happens. Look at these numbers.
Yeah.
10. So 1
Hmm.
and 3. This and this and this and this. Uh, nah, it's not easily seen as well. All right. So anyway, the idea here is this
They're
shifts.
kind of two away.
Mm-hmm.
Oh, right,
Then
really?
this kind of shifts to this, right?
Mhm.
This shifts to that, this shifts to that, this shifts to there, this shifts to here, and this shifts
Hmm.
to here. So the combination of these two numbers, these two, the 2 and the 2 inside and outside the square root, what's the overall height here right now? That's from 3 to around 3,
Uh.
right?
Mhm.
That's from 3 to 8.9. So what's the difference here? This minus this. That's 5.66, right?
Yeah.
Okay,
5.66.
5.66. What's the difference from here to here? So let me write that down real quick. So from here to here is 5.66. Then from here to here
Uh-huh.
is how much? That would be
Um.
4. I know that would be
Yeah.
2, right?
2. Duh.
Okay. Now I'm gonna multiply this thing on the calculator by 2.
Keep on looking at the top one and thinking it's the red one, but then I'm like, wait a second.
Okay. What is this divided by 2? That's
5.66 divided by 2.
uh-huh. Well,
Uh. Is that
5.66.
like
Okay. 5.66.
2.83?
2.83. So
Yeah.
2.83. Now remember earlier that this 2 times the square root of 2 is 2.83 something.
Mhm.
So these two
Oh.
numbers combined stretch it out vertically like that.
So it kind of so it
So
like makes a little difference.
yeah. So the and a times square root of b. I'll write it like this, yeah?
Mhm.
So that's what the a and b do. Most of the time you don't have a b. Your b is just equal to 1. A squared of b um, stretches graph vertically. Okay.
Mhm.
So again, a square root of b stretches the graph vertically because this 2 5.66 divided by 2 is in fact equal to 2 square root of 2, which is that.
Mhm.
Okay, that should make it clear. All right. Any questions here?
Yeah. No, not anymore.
All right. So I think we covered everything we need to cover there, right?
Yeah.
Okay. Can I just leave you with one thing for you to do and then we can end it today?
Oh yeah, sure.
All right. You
Mhm.
can do this later. You don't have to do this now. But this time now,
Okay.
I'm gonna give you f of x. I'll keep it easy, but not so easy. Okay. What is 3 equal to 3 times x minus 4 minus 10? So how does the graph
Okay.
compare to g of x equals square root of x? Okay.
Okay.
All right. So again, you want to do this now or do it on your own?
Uh, you want me to make the table
You don't have to, because
or
remember, you just have
okay?
to
So just like
know what HK and
graph
then
it.
yeah, not even. You just have to know
Mhm.
what HK and A all do.
Okay.
Okay, so identify
I'll
H.
see how to do it.
Mm-hmm.
Mhm.
K and A. So just identify those numbers and then say again what those numbers do to G of X. Yeah.
Mhm.
Okay.
Okay.
All right. I think you need to get ready for your next lesson as well. I remember you said that before, right?
Mhm.
Okay. So we'll end it here, I guess, and then maybe we can do a quick recap when we get back next week. Okay.
Okay.
All right. Or if you'd like, I'll discuss this in the stream right after you leave.
Okay. You go. You go do that or something.
All
I
right.
gotta go do stuff.
Yes. All right. So I'll see you next time
Okay.
then. Bye bye now. Have a good day.
Bye. Have a good day.
Bye bye now. Okay. lessons ended, and because Ariana usually has to leave a bit early, aside from the schedule being um the lesson being like less than an hour, and Ariana usually needs to prepare for the next lesson as well. So what I do normally is, if you'd like, if she'd like to, she'll just look at this bit of the stream. Okay. Anyway, here's the idea. Our h is equal to -10, k is equal to 4, and a equals 3. Now, what did we say earlier? H shifts, okay, g of x to um upwards. I'll just say upwards. Okay. Now, k also shifts g of x, shifts g of x to the right. Okay. And a stretches. I'll just use the word, um, the easier word to understand. Stretches g of x. Okay. That's it. It just stretches g of x. So in order for us to finally get the answer here, so let's just redo that. F of x equals 3 root of x minus 4 minus 10. So yeah, minus 10. All right. So the idea here is that h shifts g of x 10 units down. You can think of this as negative 10 units up. Okay. And then, um, okay. So I'll just remove that. K, so let's just put k in for now. K shifts g of x 4 units up. So we don't have to write that part. And then the last part is a root b. Now, in this case, a equals 3 and b equals 1. So root b equals 1. So a root b is just equal to 3. So in this case, stretches g of x 10 times, 3 times. Okay, so that's the final answer. So if you graph that, basically, 3 times compared to, again, this is compared to g of x. So finally, the last bit here is we're going to graph this. So let's set that background. Okay, so if we graph this, I'm gonna make it easy again on myself. Oops, let's undo that. Okay, let's just say that every 4 units is 1. So I'm just gonna mark 1, 2, 3, 2, 1, 2, 3, 3, 1, 2, 3, 4, 1, 2, 3, 5, and so on. Similarly, 1, 2, 2, 3, 3, 1, 2, 3, 4, 1, 2, 3, 5. Okay, so we'll just put that there. So let's do this. F of x. Oops, I forgot x. So x, f of x, g of x. So we'll start with 0, 1, 2, 3, and all the way to 4 only. Again, g of x is just root of x, right? So let's put this here, just 1, 0, 1, 1.41, the square root of 3 again? Let's see. Square root of 3 is 1.73. 1.73 and 4 is 2. All right, and then f of x. Let's put our f of x again. 3. Let's put it here. F of x equals 3 square root of x minus 4 minus 10. Okay. Let's put that in the calculator now. Uh, 0 minus 4 is negative 4, none. 1 minus 4 is negative 3, none. 1 minus 2 minus 4 is negative 2, same. 3 minus 4 is negative 1, not, but 4 minus 4 is 0, and this gives us negative 10. So, okay, so I think it's going to be more convenient for y to, if we put y here now, rather x here. Something like that. And then let's just start this with, let's just redo the whole thing. Okay. So basically what did we do now? We start, okay, something like this. So 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So let's put this as negative 10. This is 0. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Negative 10. So we're going to start off with g of x first. So let's use red for g of x and green for f of x. So g of x, we still get our normal 0, 1, 1, 2, 1.41, somewhere there, 3, 1.73, then 4, 2. So something like this curve. Okay, there. We're going to start off with x equals 4, 1, 2, 3, 4, negative 10, something like that. Okay, so let's also add 5, 6, and 7. So 5, 6, and 7, but only for g of x. So if we calculate that, 5 minus 4 is 1, square root of 1. 3 minus 10, negative 7. If we put 6, 6 minus 4 is 2, 6 minus 4 is, 6 minus 4 is 2, take the square root, times 3, and minus 10. Negative 5.76. And finally, 7, let's do that again. 7 minus 4, take the square root, times 3, and minus 10. That's 4.80. Negative. Negative 4.80. So if we graph these now, 7, 10, 9, 8, 7, then 6, 5.76, and 4, 5, 4.8, so something like that. So again, for the first four numbers, this stretched out by, from, it's going to be 5.2. But how did this stretch out? It only stretched out by 2. Now, okay. Oh, okay, hold on. Not fair to compare. We'll go 1, 1, 2, 3. So we should do, this is not 2. This is, I only should compare up to this. So if we compare up to this is 1.73. So if we do 1.7, 5.2 divided by 0.73, that should give us approximately 3. So let's try. 5.2 divided by 1.73. It is indeed 3.00. So still supports our ideas. All right. So that's where we will end. Hopefully, you learned something today. Like I said before, I'm. Hey, Jackie, I see you here. Okay, I'm read. I just saw the. Is there anyone else except for you, Jackie? Let me see on. Let me see there. Okay. Anyway, the idea here. So in case you're wondering what I'm doing, even though I'm not really a math teacher, again, ideas are the same whatever you do whenever you're problem solving, whether it's math. Okay. Where. Hey. All right. So anyway, I hope this helps you. I'm gonna stop the stream and hope you learned something. Bye everyone. I'll see you. Bye bye now. Oh, before that, before I go. All right. So again for okay. So here are the channels you can go to. If you're on YouTube, don't forget to like and subscribe. If you're on Facebook, same thing. Share if you can. Twitch, I just stream there, so just follow us there. Okay. Now, TikTok and Instagram are now active. They're all Freaky Physics, just so we're clear. Um, and since they're there, just follow there because I'm gonna put the shorts there every so often, the condensed versions of whatever we're doing. So it's gonna be an easier explanation. But of course, for practice, you still need to practice properly. All right. So with that, last thing before I go. Hmm. Okay. Let's see. Let's see who was in the chat since the beginning. All right. So for those who are watching, thank you again. Um, yeah, I'm just watching now. Yeah, I couldn't read your chats earlier because I was focused on my other screen here. All right. Okay. See. See. All right. Now I just gotta ask you now, since you're all here. Now, for those who are new to the stream later, these are actually my students in school. Right. So you guys, please, as usual, thank you for doing it anyway. But as usual, I want you to behave. Set a good example for the rest of the stream. Yeah. All right. With that, I will end today. So thank you, everyone. I'll see you. Bye bye now.